Good morning, everyone. We are going to hit our last topic of the unit today. Our last topic of our transformations unit is symmetry. We're primarily going to just talk about it in two-dimensional figures. So a figure has symmetry if there exacts a rigid motion, such as a reflection, which we've done, translations we've done, or a rotation that maps the figure back onto itself. So it's kind of like when we were talking, when we talk about like 360, right? If I take this pen and I rotate it 360 degrees, it brings it right back onto where it was. Okay. Line symmetry is reflection symmetry, where one half is the reflection of the other half. So, for example, let's see. Get a sticky note here. All right, here we go. So this is a square, right? If I fold this in half, that is line symmetry. Okay, it's exactly cutting that shape right in half. The line of symmetry is a line that can be drawn through a figure so that the figure on one side is the reflection image of the figure on the other side. So that would be the line of symmetry. So in these pictures, we're going to look at them. We're going to state whether they have line symmetry or not. And if so, we're going to draw the lines of symmetry. And there can be more than one line. So if I look at this crab, if I cut it in half this way, there's different claws on the top and the bottom. However, if I cut it this way, I see two mirror images. So this can be a line of symmetry. So this does work. Yes, it has a line of symmetry, and there's only one line. This starfish has these 5 equal tentacles or legs or whatever you want to call them. So coming off of those legs are 5 lines of symmetry that all meet in the middle, and then these are all equal symmetric parts of the starfish. So yes, this has lines of symmetry and it has 5 lines. Over here, if you look, I think this is like a shell of some sort. If I cut this shell this way, those two sides are not the same. If I cut it this way, they're also not the same. So this does not have any lines of symmetry. If I look at this shape here, if I draw a line, I'm going to do this in pencil. If I draw a line here, if I tried to take this shape and fold it over, it would go like this. Okay, so if I took this and I folded it over, it would look like that. So that means it does not have a line of symmetry that way. If I took this and cut it this way and folded it over, I would also end up having this come here. This would overlap here. Okay, so this does not have lines of symmetry because it's got that slanted motion. This is very similar to the starfish. If I take a line and put it at each vertice, remember vertices are just those corners, I can make these 5 equal triangles. So yes, this has lines of symmetry. It has 5 lines. This one, I can cut this rectangle in half. It's kind of like, if you remember from elementary, hot dog or hamburger style. So hot dog, this would be hamburger. So I can cut it either way and make the paper equal. So if I had like a full-size piece of paper, like the one I have right now, if I flip it over to where it's blank, I could fold it hamburger or hot dog style. Either way, it's going to be, this is hot dog style. Either way, it's going to be equal on both sides. So I would say yes, and this has 4 lines. 2 lines. 1 line, 2 line. 1, 2. Okay. This technically is going 1, 2, 3, 4, 5. Because those lines aren't going right into each other. If I kept this one going, it'd be like that. Okay. All right. The other thing we have to look at is rotational symmetry. Rotational symmetry, or sometimes called radial symmetry, is if a figure can be mapped onto itself by a rotation, between 0 and 360 about the center of the image. The center of rotation is a fixed point around which the shape moves in a circular motion to its new position. The order and the magnitude are some key things we're going to talk about. The order is the number of times a figure can map onto itself as it rotates from 0 to 360. Some shapes can map onto themselves only once. Some can't. Some can not map onto themselves at all. Some can map onto itself multiple times. The magnitude of symmetry is the smallest angle through which a figure can be rotated so that it maps onto itself. So some shapes can only be mapped onto themselves once, which means the only degree would be 360. Some can map onto themselves multiple times, so maybe they map onto themselves every 45 degrees. So things like that can happen. The specific rule we use here is magnitude equals 360 divided by our order. Now, when you're finding the order, I like to write over here that you are counting distinct features of the shape or image. So in this, I have this weird kind of piece here. There's another one here, and there's another one here. I have 3 distinct figures. Now, I'm not going to also count these and say I have 6, because those are different distinct figures than these. So I chose this as my distinct feature. I have 1, 2, 3 of them. That means my order is 3. Now, if I want to find my magnitude, I have to use this rule. So I have to do 360 divided by my order of 3, and that would give me a magnitude of 120, and it's a degree. This one has 2 distinct features. So, and the reason I'm saying that is if I took a Z, do it on a piece of paper, if I drew a Z, if I took this Z and rotated my paper 180, so I'm just flipping it up to down, the Z looks exactly the same. So these 2 features are the same. If I flip it again, I'm back to where I started. So I can have an order of 2 here because I can move it 2 different ways before I'm putting it back onto itself. I have 2 distinct features. This means my magnitude would be 360 divided by the order, which is 2. And that gives me 180. That's because I took this Z, I rotate it 180. Okay, it mapped back onto itself. I rotate now another 180, which puts me at 360. And that's also back onto itself. So I can map it back onto itself twice. That means my magnitude is 180. 180 is the smallest angle at which I can map it back onto itself. This one, the distinct features, I'm just going to look at these little squigglies in the middle. I have 1, 2, 3. So my magnitude, once again, would be 120 because I'm doing 360 divided by my order, which is 3. This one, I'm going to look at these sharp features. I have 1, 2, 3, 4. So my order would be 4 here. My magnitude would be 360 divided by 4, which is going to give me 90 degrees. Okay. Now we're going to look at some traditional shapes here. We're still going to use our rule. So the question here is, do the regular polygons have rotational symmetry? Now for each polygon, we want to find the center and the angle of rotation. We're going to find the order and magnitude of these, okay? And remember your rule. So here's my center of these, okay? We want to find out what our possible angle of rotation could be. So I want to find the order and the magnitude. So I just look at distinct features here. I have this is an equilateral triangle. So I have 1, 2, 3 vertexes, and they're all equidistant from this point. These are all equidistant lines because this is an equilateral, meaning all sides of this triangle are equal, which we will get more into later this year. So that would mean if I have 1, 2, 3 distinct features, I have an order of 3. So my magnitude, going back to my rule, is 360 divided by my order, So that would give me 120. The square has 4 vertices. 1, 2, 3, 4. A square is also, all of these vertices are going to be equidistant. So I can take this and rotate it. 1, 2. I can rotate it. So let me actually make a little square. I already had one before. So if I take this square, right, remember that my original stance for this square, this little hole's on the left side. So if I rotate it once, that's the same square. I rotate it twice, it's still onto itself. It's the same square. Actually, an easier way for you to see it is if I even trace this square, right? 1 second. Oop, my lines went a little over there. Sorry. All right, so I just traced my square. I messed up a little there, but that's okay. If I rotate this, let's see, 45 degrees. Okay, you see how this doesn't map onto itself? If I rotate it from the start 90 degrees, it maps back onto itself. I rotate 90 again, it maps back onto itself. 90 again, 90 again, it's back where we started. So I was able to go 90 one time, 2 times, 3 times, 4 times. That is why my order would be 4. I was able to turn it 4 times and still map it back onto itself each of those 4 times. That's why my order is 4 and my magnitude is 90, because 360 divided by 4 gives me that 90, and each turn I made that mapped it back onto itself was another 90 degrees. So hopefully that resonates a little bit with you after seeing that. The regular pentagon, I'm just going to count all those vertices again. 1, 2, 3, 4, 5. Once again, those are equidistant. So when I turn it, should map onto itself 5 different times. So my magnitude should be that 360 divided by my order. 360 divided by 5 gives me 72. And my last one here is my regular hexagon. I'm going to count all those vertices. 1, 2, 3, 4, 5, 6. So my order is 6. Once again, I'm going to do my rule, 360 divided by the order, and I get a magnitude of 60 degrees. All right, so hopefully symmetry is pretty easy. Hopefully you think so too. All right, so what you guys are doing today is you're going under the classwork tab. You are getting started on this quizzes. That's all you owe me today. I preferably want you to get it done today. If you have a lot going on for some reason, it is not due till tomorrow at 11:45 p.m. because the quizzes does not let me put in midnight. So it's 11:45. All right, guys. Hope you have a wonderful day. Make sure you reach out, jump on my call today if you need help. Bye.